before I start graphing. That's gonna help us. Who can remember any of them? Okay, period. What's my formula for period, Declan? Do you remember the formula for how to get our period of a function?
Oh, yeah.
Declan. Thank you, Kian. Kian, you do the next one. Okay. Wait, Declan's getting set up. Go ahead, Kian. P equals what? Absolute value of B. Perfect. Okay. Yo, do you remember any other ones that we were doing? What letter does it start with? A M P? So that's amplitude. So amplitude. I don't want to spell it out, but it's amplitude. So we just used A. So absolute value of A. Okay, next one. Declan, you want to do it? 3 or 4. Either one. Anything. There's just 4 things we have to do. Yeah, so do you know what F means? Like, what's the word for F? Yeah, frequency. So we're talking about frequency here. So 1 over our period. The last thing was our jump, which is a new thing for us. Well, new thing for everyone, which is P over 4. Okay. That's where we're starting off. We're going to get on the boards and try to graph these. What? For F, it's 1 over P, yeah. Because it's just the reciprocal of RP. So we're just flipping RP the other way. Okay. Feel ready? To go up and do it? Yeah? Okay. Groups. We have 1, 2, 3, 4, 5, 6, 7, 8. I gotta do 10, 8. Okay. Do we want to do 4 groups of 2 or groups of 3? I feel like that's a lot. Let's do groups of 2. Yeah?
Yeah.
I don't remember what we had yesterday. Oh my god. Oh, group thingies. Do you guys remember what it was? Okay, if you remember, go with your people. If you don't, that's okay. I don't have them up anymore.
Did you end the other recording or is that the same?
No, it ended. Yeah. Who remembers who? Lucy? And who were you with? Jade. Group. Declan, who are you with?
Jade, but I'll pick.
What's his name? Yeah, okay. You just pointed to him like you didn't know his name. Okay. Yell. Beatrice, let's do this. No, yeah, erase everything.
I haven't done it before, so. My unit circle's blank. Still.
If you have a unit circle, David, it'd be super helpful to have.
let's make a chart. Three cosine 2x.
What do you guys think?
Three.
So before you start making your table,
I don't know. I've never done this. I'm just
okay.
copying what we did last.
So let's check it out. I'll tell you, sine and cosine. This is some change of it. Right? Like this is a change of sign because it's not just sine x. So let's just run through. For sine and cosine, it's always 2 pi over b. So you also forgot x, right? Just so you know.
Yeah, I didn't finish it.
Okay.
Do you
Oh, you should, yeah. All right. Is the x in the numerator or denominator? Like, if you were to multiply it, would it wind up? And you can't tell here either. Like
denominator.
why?
Numerator. It's
If I did 1/4 times 1, I'd get 1/4, right? Like so, that's a numerator. So when we're writing these, I'm gonna write this up here.
1x and 1/4.
A sine of bx. Is that in that form?
Yeah.
So what is b in this problem?
1/4.
Good. So over on the left, I would write period, and I just use PER, but half of p is sufficient. For sine and cosine, it's always 2 pi divided by b. So don't forget your pi. Good. With b. Yeah. So how do we divide by a fraction? Is that going to throw it into? I have a number divided by a fraction.
A bigger fraction.
Maybe. I mean, it will be, but it doesn't. This is what I think it would be. If you don't want it,
Flip it.
keep changing flip. I think it's the language you guys grew up learning. I just say multiply by the reciprocal.
What does that mean?
So if you flipped the bottom, what would it be? Instead of 1/4, it'd be
4 over 1.
And if you multiply that by 2 pi, 8 over 1.
Well, how could you just flip the bottom and not the top?
Well, because we're not really flipping it. Like you're asking why the math works. 2 pi divided by 1/4. I don't want to do that, right? But could I multiply by 4 over 1 down here as long as I do it?
I thought you
here?
were just changing that.
Well, yeah, like when you do this, typically what happens is you just erase that and say, oh, let's just multiply it.
Okay, 8 over
8
pi.
pi, there it is.
8 pi over
And
8.
and that Declan just like you do not have to show that work. This is why it happens. I want you to be able to say that, oh yeah, it's just the same as that. That's multiplied by 1/4. Okay, so we have the period. Amplitude, which is like from the middle of a wave to the crest or the trough, or the min or the max. What's the amplitude? Knowing that it's A on your graph.
3.
Yeah. Amplitude is 3. So right, amp equals 3. The frequency we can do easily. It's 1 over the period. And you said the period was
1 over.
Oh,
good. That's your frequency. And then this is the one that I care more about. Is if you take the period and multiply it by 1/4 or divide it by 4, either way. What's 8 pi times 1/4? Or 8 pi over 4, because they're the same thing. 2
Pi.
Good. Okay. Now I'm gonna make you physically do the 3 column table, so you're gonna have to scratch for me, okay? Just so you know, sine and cosine, 0 is 0 for sure. And then, like, I want you to plug it in here. 3. So I want you to show this work. I don't care. Are you okay with 1/4 times 0 is 0? So I want you to write 3 times the sine of 0. And then sine of 0. So here's I'm thinking about the circle. 0 degrees is right here. What's the y value? Yeah. So that's what's sine of 0? What'd you change?
Sine of 0.
You just told me sine of 0 was 0 and 3 times 0 is 0.
We pick.
Nope, don't pick. This is our jump.
Oh, I thought we
So
it was 0,
I-
-1.
I want you to see what happens with it. Like that's why we do the jump. Add 2 pi. Okay, and now this is going to be 1/4 of 2 pi. If I do 2 pi over 4, is that just pi halves?
By half.
Like, and I'm asking, do you see how we get pi halves there, Winslow?
Because
So that's okay. Do write it in your deck 1/4 times. What are we plugging in for that theta? 2 way. Good. And then what's 1/4 of 2 pi?
Pi.
Pi over 2.
Pi over
So write another line for deck. 3 sine of pi over 2. And then I want you guys to both look at the unit circle. Before you look, can you point to pi halves for me? Do you know where pi halves is on the unit circle? Then pi. Pi halves. What's before you look at the unit circle? What's the y value here? So we're at
it's 0, 1.
so what's the y?
0, 1. It's the top one, right?
Yeah.
0.
Good. So just the y value. We're looking at sine.
So
3 sine of
3 times
pi
y.
halves. So you're trying to mix steps. Love it. Now, what is this? And that's where you're trying to write the 1.
1.
So 3 times 1 is 3. Yeah. And I want you to keep kicking. Your jump is what you change by every time. If you were at 2 pi, where are you now?
4 pi.
Yep, keep kicking.
David, the my notebook. Yeah.
I'll read.
I is 0.
It'll be a smaller one.
0.
You can borrow it for now. You gotta make one there. Ian.
No, I have it. Are you using it? You did that too.
Straight.
Yeah. So like, could I write this if I wanted 2 pi?
Oh.
220. Then I could make it 2 pi.
1 for the
More base pool.
0.
If you type it in the calculator, you're going to be wrong, I'm pretty sure. You've got 8 pi.
With you. 8 pi.
So, yeah.
That'd be
but hold
0
on.
though.
Ooh.
Yeah.
There's a pattern?
Yeah.
Oh, it's like it starts at 0 and then it goes up in amplitude, down and down and up. Oh.
Ready for you.
Oh, I had to write that down too. 4.
4 pi over 4. You have to count it by 2 pi. Strike 3 sides.
Okay.
How do you?
What is
This way, this way.
So it's 2 pi.
4 pi 0.
Pi over 4.
6 pi.
yeah. So then say
Crazy.
Goes. But this one's technically done.
Find my domain's range. Function. Okay. So a full cycle sine goes from here
Yeah.
and here, right? So I need to know the up curve, down curve, and then empty. That's a full cycle.
I would go in the past. -2 pi minutes.
Gotta keep going. I want a full sine curve.
Sine
So from here to here
we kind of have.
is 1. What would I? You got enough space.
You need how many? 2?
So if one curve goes from 0 to 8 pi, I go another 8 pi. How many pi's am I at? 16 pi's.
I'm not gonna write pies.
One. That's 1 over 6. So
I go to know. Go.
Now let's do an x up. Let's get all the x up.
Betsky. I'm gonna make this.
I'm gonna go up to.
Since we have the time.
last time we had 3.
Sine. 1 fourth. Okay. For the guys that are done, do you want to put in your notes? Do you want to know how? Okay, put it in your notes. Like copy and go. Yeah. No. Copy and go. Okay. What is 1 fourth times 4 pi is 1 pi? It's just pi, right? Okay, so what is sine at pi? Yep. What is sine? What is sine? And what is 0 times 3? Yeah, even good.
Yeah. And that's over here.
Do that or give you a problem.
New problem on it.
Okay. Alright, next one. Let's do. Ooh, that was kind of tricky. Do y equals negative cosine of 3x.
So every word that we found.
A is negative.
It's not bad. I understand.
It's negative 1 and
It's like what
Oh yeah. The absolute value of negative 1 is 1, right? Yeah. It's 1 over p.
But then you said it's like it's 5 over 2.
What's 1 over 2 pi over 3? Or is it, can this go fast?
So the jump in this one was what? It was period over 4, and period was
What's this? Jade, what's 2 pi over 3?
It should have been period equals 2 pi and always got B. Always got B. Then we do 2 pi over 1/4. Then we do a little quick change flip. It's 2
It's the only one missing.
pi over 1.
Can we just
And then pi, you put right on top of 4. And that would give us 2 pi. So this is my
first one?
So
2.
that means if I can start at 0, I want to add 2 pi each time.
Well, you're not taking
The most important things on these is period and
Ask a sweet question.
the amplitude just is like a big track and frequency is a check.
Sweet. Can this be simplified more? The P.
No. That's about it. Yeah.
1 over. What's 1 over 2 pi? Multiply both sides. Just erase that, bro.
I used to
Click to you.
Like this one or one. Did you write it in your notes? Okay, y'all, did you write it in your notes? You writing it now? Okay, you guys look good too. We all. What did you do? You didn't like it? Okay. How do we feel? Thumbs up, thumbs down? Do we like well, not if we like graphing them, but was it easy or was it hard? Thumbs up for easy, thumbs down for hard. Do you want to do that one? That one wasn't hard.
I don't know what to do.
Okay. Okay, let's try another one then. That's totally fine.
Can I write down the problem?
We're gonna write down a harder one. Maybe. Yeah. You can take a picture of it though and write it down later. Yeah. Okay. Negative cosine of 3x. Okay, this is the next one. I need to find 3 things. First, second, third, and fourth. First thing is always our period. What is my equation of a period?
B equals 2 pi over.
Yep. What is my amplitude equal to?
Absolute value.
Yeah, absolute value of -1, which would be just 1 in this case. Frequency. What is just the formula for frequency? Thank you. Lucy, my last thing is a jump. What is my formula for a jump? Close. It's just my period over 4. Yeah. You know what I'm saying? Okay. First one, period. We have 2 pi over the absolute value of what? What is our b, Wenzel? What is my b in this equation? Yep. B is, it's right next to the x. What's the number right next to the x? what is my b in this function? So like a normal function would look like y equals a cosine of bx. So what is b? 3. Perfect. Okay, so that's just 2 pi thirds. So that means my entire curve is going to go from 0 to 2 pi thirds. So that's start and end.
That's find the sign for the cosine.
No, we'll either get a function with sine or a function with cosine. They're entirely two different functions. I would. No, we don't need the points yet. Yeah. Okay, amplitude. Yep. Okay, next one, frequency. So we put 1 over 2 pi thirds. Declan, how do I simplify this? Okay, do you remember keep? Okay, do you remember keep change flip? Okay.
Wait, do you multiply by 2 pi?
Wait, you keep 1. Our numerator, you keep it. We change division to multiplication. And then our fraction down here, we flip it. So now I have 3 over 2 pi. Like what I just did? Okay.
Cool, I just don't know how that helps the situation. I know what you did, but...
Because right now, there's a fraction inside a fraction, right? Yeah, that's like the ugliest thing imaginable in my head right now. A fraction inside of a fraction, you can't really simplify it. So to simplify it, we get rid of this fraction bar by going to multiplication and then flipping this over. Because this just simplifies to 3 over 2 pi. Yeah. Cool. This is telling us that we're going to have 3 complete cycles of cosine from 0 to my denominator, which is 2 pi. Jacqueline, what do I do next? How do I do that? Yep, what's p? Pi over 3 over 4.
Multiply by 1/4.
Not really. Because I multiply by 1/4, I would just put 8 in the denominator. No, we can do? Keep, change, flip.
That's what I just said.
That's not what you just said.
That's
What do I keep the same?
4.
I keep my numerator the same. Always my numerator.
Multiply by 1/4, because you flip it and then change it.
Okay, yeah. Sorry, that's not what I was getting when you said that. I thought you just want me to multiply this entire fraction by 1/4.
No, I do, but...
Yeah. It's 3 complete cycles of cosine. So cosine, which is just cosine. Yeah, all the same. Okay. Multiply this out. I get 2 pi. What's my denominator? 12. How do I simplify this fraction? Yep. Pi. Yeah. Pi 6. Divide the numerator and denominator by 2. Okay.
That's going to be 0.
Yes, we're going to start at 0. Guys, I'm going to have to scooch down a little bit. Sorry. Do we like 3 column tables?
No.
Honestly, I promise you, you're going to need...
Is it two,
We're going to need this one. So we have negative cosine of 3x. We have x and we have y. Yeah, what x value do we always start with? 0. Perfect. And then I have to jump each time. What am I jumping by, Lucy? Yep, pi 6. So pi 6. And then if I add another pi 6 to that, what do I get? Just add the numerators. The denominator just stays the same. So I have 1 pi plus 1 pi. Perfect. 2 pi over 6. Okay, add another pi to that. Yeah, we're going to simplify it. So it's just pi over 3. Add another pi 6 to it, Lucy. What do we have?
4 pi over 6.
Add just one more pi up to the top. So 2 pi plus 1 pi.
3 pi.
Yep, 3 pi over 6, which is the same as,
1 pi half.
yes, yes. You said over, you said half, that's good. Okay, I gotta get up to 5. I'm at 1, 2, 3, 4. Okay, add another pi 6. Lucy, where am I at? Wait, okay, I'm at pi 6, then went to 2 pi 6, 3 pi 6,
4 pi 6.
yep, 4 pi 6. Jade, what fraction does that simplify to? Yep, 2 pi thirds. Perfect. Okay, those are my fractions. That's what I'm putting in as my x value. Okay, Kian. Negative cosine of 3 times 0. What is 3 times 0? 0. Okay, what is cosine at 0? 1. And then I have it multiplied by negative, so my y value is? Negative 1. Perfect. Okay. Beatrice, next one is you. Negative cosine of 3 times pi 6. So 3 times pi 6, I can put all together the 3 pi 6. What fraction does that simplify to? What? We'll see in a second. 3 pi 6 over 6. I'm sorry, 3 pi over 6, yeah. What fraction does that simplify to? Yeah, so pi halves. What is cosine at pi halves? It's going to be my x value. Yeah. So it's 0, and 0 times a negative is just 0. Okay, Declan, we have negative cosine of 3 times pi thirds. What's on the inside? What is 3 times pi?
3 pi, or just pi?
Yep, just pi. So what is cosine at pi?
1.
Check again. So,
Whoa, negative 1 times.
yep, negative 1, and then times the negative is just 1. Perfect. Okay. Kian, we have negative cosine of 3 times pi half. What would the middle simplify to? Okay, what is cosine at 3 pi halves? Zero. Perfect. One's L. Next one's U. Negative cosine of 3 times 2 pi over 3. What does the inside simplify to? Wait, don't look at the unit circle yet. What does the middle simplify to? What is 3 times 2 pi over 3? What does that simplify to? What is it? 2 what? Don't forget your pi. 2 pi, perfect. So what is cosine at 2 pi? 1, yep. And then 1 times the negative is just 1. No, it's negative 1. There we go. Perfect. Try to graph it. Cool. Yeah. We're almost done, actually, with this. Yeah.
And we'll have a test about it?
Yeah. Next week.
Perfect.
I'm trying to not have it on the same day as geometry because I feel bad for the students that are taking both. Well, geometry, you guys are going to take it. Oh, yeah, Thursday. Never mind. Yeah, you guys have to do Thursday. None of you are in geometry either, anyway. So, yeah, Thursday it is. Yeah, Thursday. Okay, I'm going to graph it up here. So don't look if you don't want to know. I'm going to graph it up here. You're done. Graph another full cycle. Graph all your cycles until you get to 2 pi. Oh my god, that's like my best graph so far. I know, right? I would make your like x values just the easiest thing ever, and just do whatever these x values are, and just stick with the same pattern across. If you graph other cycles, make sure you're doing it as dotted lines. Yeah, the end here. Okay, and then these dots, like dotted. Yeah. Did you keep going? Keep going all the way up to 2 pi. You can go in the negative direction too. I'm also gonna run out of room, so I get it. Okay, I'm graphing another complete cycle right there. Oh, there we go. How do we do? Yes, just end right there for original function, and then you keep going. So you get here, it's just one person.
Yeah, I
Yep.
definitely did that. Oh,
Oh,
I put Donna.
okay. Then just indicate the cycle by doing dotted lines after the first one.
Is that a negative?
Oh, negative.
No, negative is perfect. You can 100% go in the negative direction.
I got space.
So I can also go this way as well. Okay. Okay, quick check. If I had a graph like this, and I graph a function that looks like that, is that sine or is that cosine? Wait,
That's
wait, close your eyes. Close your eyes. Close your eyes. Raise your hand if you think it's sine. Hands down. Raise your hand if you think it's cosine. Okay, hands down. Okay, open your eyes. This is sine function. This is sine. If I'm starting at 0, 0, this is sine. If I'm starting somewhere on my y-axis, then it is cosine.
technically it is still on the y-axis.
Well, yeah, but I'm not going up or down. I'm starting right at the origin.
First wave goes down, it's cosine.
No, it can. Okay, if I graph this, Kian, if I graph it like this, that is still sine. If I graph it like this,
Yeah, that's what I was thinking.
that is cosine.
Because it starts on the y-axis.
Yeah, because I'm like up. If I start down below, that's really fine too. That's what we just had. We just flipped it over. Yes. That is a good indicator of what sine and cosine is. Yep. Okay. Good job. Here's your homework. I know. Yes. Well, we've been doing this for like 3 days. So it's not. Yep. Homework. Wow, it's big. This is 7.3, page 370. We're going to do 5, 6, 10, 13 to 15, 17. What was that? What? I saw that at the corner of my eye. 17, 18. That's your homework. It's 8 problems, I think. 1, 2, 3, 4, 5, 6, 7, 8. What?
All of them are graphic.
I think these are graphing. Huh, that's funny. I think the first 3 are not graphing. Yeah. I think more of them are not graphing. No. Do you want to do a brain break? Okay, we'll do a brain break and then we'll go on to our next function. Guys,
Interstellar travel.
you want to talk about interstellar travel?
Do you believe it's possible? Yes.
Okay, the question is, can we go at the speed of light? We should probably stop this recording.
Negative energy.
Okay, there you go. Zoom in. And now we get to clear. Okay. Okay, we have done sine and cosine. We're not done yet. Okay, this is 7. Oh, not that fat. This is 7.5. We're skipping 7.4. We're not talking about it. Because you do it in Trig, and it's not entirely important right now. Graphing other Trig functions. So we did sine and cosine. What is left? I mean, they're all on your calculator if you want to check. It's going to help you. Okay, so we still have tangent. What else?
Sine.
Oh, wait, we did sine.
Oh, you're talking about new ones?
Yep, our new
Well,
ones.
there's a bar is fun.
A what?
The only ones I see is sine, cosine, and tangent.
So we have cosecant
Oh, that's
of x. We have secant. And we also have cotangent. Not really.
that's not on.
You don't have to. It is
I don't think
somewhere.
it's vector.
So CSC is cosecant. SEC is secant. You can get it on here though. I just don't know how. I don't use that calculator. I use my own. Well, my calculator has them on them, so I was surprised. They don't even have them on here. Okay. We're going to start with tangent. What do we know about tangent?
The sine
Yeah, go ahead. Yep, sine over cosine of x. So that's what we're dealing with. That's what we are graphing. Who remembers chapter 4? Anybody? Okay, I'm going to tell you right now. On your test in chapter 4, you had this problem.
Yes.
Over,
Yes.
right? Okay. We had to find some vertical asymptotes. How do we find vertical asymptotes of this function?
It's the.
What is it? It's else. It's
No, that's the.
To set something equal to 0.
Oh. What is it?
We set our denominator equal to 0. That's how we find the asymptotes for vertical asymptotes. We're going to do the same thing here. In tangent, what is my denominator? Cosine. So cosine of x. Where is cosine x on a unit circle?
Just X?
Where's cosine 0? So looking at my points.
2 pi.
Okay,
Then,
2 pi?
but
Let's see, is cosine or x or y coordinate on the unit circle? X. So where do we have 0 as our x values on the unit circle? Okay, I hear pi halves. Where else? 3 pi halves. Okay. Those are going to be vertical asymptotes for tangent. Okay? So if we keep going, we have it again at 5 pi halves. And again at 7 pi halves. I'm going to keep going around my circle forever. And it just keeps going ever and ever and ever. Can I go in the negative directions too? Yep. So it's in the negative directions as well. So I'm going to start tangent like so. I have negative pi halves and pi halves. And we have a vertical asymptote at both of these. Can I cross a vertical asymptote? No. Cannot. So vertical asymptote can not cross. Because that's denominator and tangent. It's always going to be true. Denominator and tangent is cosine. Yep. And we have a vertical asymptotes right there and right there. Okay. Let's do our table. We only need 2 columns for this. We have x and we have tangent of x. Okay, we're going to pick values in between negative pi halves and pi halves. Okay? So let's start with, well, negative pi halves. What's the next one you want to do? That would be my last one. Pi halves. Down below. In the middle will be 0. And then we'll do pi fourths and pi fourths. Yeah. So what is tangent at negative pi halves? Let's look at our unit circle. Okay. If I'm a negative radians, I'm going in the clockwise direction. So I'm going down now. So I'm going down a pi half. Where am I at? 0, negative 1. And then what is tangent at 0, negative 1? Yep. Do you know why it's undefined? Yep. Perfect. Okay. So that means over here, we have undefined. And then I'm going to pick up my thing again. Okay. Oh, this was negative. Wow, this is tripping me out. Okay. Okay, next one. I'm at 0. I want tangent at negative pi fourths. So I'm going to go down to what radian? Yep, 7 pi fourths. Any questions about why we're here? So I have a negative radian. So I have a negative radian. Move clockwise. So let's do this. Move clockwise on unit circle. And these are positive. So we're going to move counterclockwise on unit circle. And then 0 is just 0. Okay, back here. So Declan, where am I at again? Okay, we're at 0.
Yeah.
And I want to move negative pi fourths. What direction am I going in?
Good.
Clockwise or counterclockwise?
I think counter.
Clockwise. Yep, down here.
Couldn't think of the word.
And where do I stop?
At negative 5/4.
Okay, what is that with a positive radian?
4 5/3.
So
7 pi over 5.
7 pi fourths. So I go from 2 pi, which is the same as 8 pi fourths, and I go down 1 pi fourths. So I'm just going to go down a pi fourths. So I'm at right here. What is tangent at this point? Yes. Do we all know how we got negative 1 for tangent? Okay. So, sorry, that disappeared. I know. Tangent of theta is sine over cosine. Okay. Declan, do you have your circle in front of you?
It's still not filled out.
Okay.
Let me know when to fill it in.
Who's supposed to know signal?
Oh yeah,
Okay. If we're at 7 pi fourths, Declan, what? What did you have to do?
help my mother.
Okay. Sure. Let's move on. 7 pi fourths. That's where we're at, right? I'm talking to you. We got 3 minutes. Declan, we're at 7 pi fourths. What is sine at 7 pi fourths?
For
The value of sine at 7 pi fourths.
0.
Okay, look at 7 pi
Negative
fourths.
5/4.
Look at 7 pi fourths.
Yeah.
Where am I at? Okay, so we're going to go to a coordinate.
So that's
So this x value is for cosine. This y value is for sine.
the negative.
Over, yep, 2 over 2. And then what is cosine at 7 pi fourths? Yep, and if I simplify this fraction, what is it going to equal since they're both the same number?
Plus or minus.
Just negative. Negative what? If I had,
Or just 1.
yeah, just 1, because it's the same thing in the numerator and denominator. So negative 1. So that's how we got negative 1. Yeah. Okay. Tangent at 0. What is the tangent at 0, Kian? No, you know tangent.
0.
It is. Yep, 0. Yell. What is tangent at pi fourths?
1.
1. Yep. And then what is tangent at pi halves? Jade. Unit circle. Yep, undefined, because this is our asymptote. Undefined. So let's graph this really, really quick. This is negative pi fourths, and this is pi fourths. Okay, we are undefined here. At negative pi fourths, I'm down at 1. Then I'm at the origin. And then I'm at pi fourths, and I'm up here at 1. Now, Beatrice, I can never touch my asymptotes, but I can get really, really close to them, right? So I can get really, really close, but I can't touch them. And I can go up. Oh, it's going to look a little funky.
Oh, tangent looks like the one straight line, huh?
Wow, this looks awful. Wait, give me a second. Let me make them a little bit closer. This would be 1. This would be negative 1. And that is it. So it goes like that down, and we get really, really close to the asymptote, but we don't touch it. And then we change direction. We go up. We get really, really close up there. Okay, that looks awful. Up there.
Is there asymptotes in this? Like, it never touches the next one?
Yeah, it's never gonna touch. So it should look like that.
Well, what's this thing about?
That is tangent. And there's no asymptote over here. We'll talk about it tomorrow. You got the homework. Good